Okay, I do want you to think. This is what we're here for. I do believe that there's a stereotypes about, all evolutionists have got to be atheists. Well, that's just not true. And there's a group handing out flyers outside there giving examples of evolution-believing people who are also God-believing people. I've met Dr. Collins, the head of the National Institutes of Health, because he's from the same town my wife and I met together at. We met him at a book signing, and I know he plays the guitar in church. The big thing to do and the take-home lesson is stereotypes may be based on some kinds of baseline of data, but basically stereotypes are unintelligent. You cannot apply broad brush to everybody. Not all evolutionists are atheists. Lots of them are Christian believers, like me and like Dr. Collins. Mary Schweitzer, who discovered the red blood cells. When she did that with that T-Rex bone, I wrote her an email right away because I knew she was going to be stuck between a rock and a hard place. I said, look, I'm praying for you, because she is also a professing Christian, but she also believes in evolution. I knew all the evolutionists would be mad at her, and I knew all the Christians would be mad at her, the creationists would be mad at her too. So I said, look, I just want you to know I'm praying for you. I never got an email back because she probably got 1,000 emails that day, but I wanted her to at least know. I appreciated her position. But when you discover something, even Charles Darwin said, what I am putting forth as my theory, I feel as though I've confessed to a murder. Anybody who has a theory or discovers a fact, anything that goes against the general flow of what everybody thinks is true, they know they're in for a fight. And Darwin himself was a very shy man. He had stomach problems and he didn't like publicity, so other people took up the fight for his theory. But let's go on to Big Bang. I want to just let you know, I want you to think. Think. That's, God gave you a brain. We want to use it. And people who say you shouldn't, that might be some fringe group in my Christian brotherhood. And people who don't want you to ever consider any other options but evolution, I'm hoping that's a fringe group in the evolution camp too. This is a marketplace of ideas. It's a university campus, one of the biggest ones I've been to. I've been to Ohio State, might be bigger, but I haven't seen all of yours. It's a nice place, but thinking is important, it's good, it's what you're supposed to do. Come let us reason together. That's what we're all about. I don't think anybody should be about any process that is a non-thinking process. James Klein from McGill University said 10 years ago, in American Scientist, where did matter come from? The best theories of the origin of the universe still fail to explain how the universe managed not to turn up empty. Where did matter come from? How did the universe not turn up empty? So 10 years ago, Big Bang Theory wasn't, giving everybody the closure that was needed. This does not mean it's not a good theory. It's nice as theories go. But it also indicates this is not a done deal for anybody. To teach it as though it's a done deal, though, that's a little either too casual or deceptive. Depends on what level of knowledge you have in the field. So this is the title of my talk, Big Bang's fake, and I can prove it. Fake, if it's presented as a done deal, as a proven scientific principle, I think that's disingenuous. As far as a model, as a construct, if that's the way it was presented, then it wouldn't be a fake, it would be a real idea. But ideas have to stay in hypothesis mode, at least limited to theory, before you go around telling everyone, if you don't believe this, you're really out of it and you must be unintelligent. Don't you think if I were wrong, I'd know it, is an attitude that we do find. And yeah, Sheldon Cooper's probably the best. I tested out on a personality thing, those little things on the internet, I tested out as him. I wanted to be one of the nicer characters in the, but anyway. Cover of Discover magazine, 2002, well-known evolutionary cosmologist Alan Guth said, this is right on the front of the magazine, the universe burst into something from absolutely nothing, zero, nada. And as it got bigger, it became filled with even more stuff that came from absolutely nowhere. That is what the Big Bang Theory says. A lot of people don't understand that evolution says that fish turned into monkeys and the monkeys turned into people. You need to go the whole enchilada and understand what you're buying here. And this, of course, the beginning of the universe is what you're buying, a violation of the first law of thermodynamics. As Bruce Malone said, first law of thermodynamics says matter energy cannot be created nor destroyed. But the Big Bang from the get-go violates that and says all the matter and energy in the universe was at one time created. That's a step of faith. That is a miracle. And I have no problems with people believing in miracles. I do. I happen to believe in God, so I believe miracles, if God has power to do that, yeah, miracles can happen. But if someone says, I don't believe in miracles, but I believe in the Big Bang, I'm sorry, you do believe in miracles. I spoke at University of Texas, El Paso, and in 2 sessions, over 5 hours, the Atheist Club members were there, testing me and hassling with me. I actually got to like some of them. And at the very end, I finally got all the Atheist Club members to admit they believed in miracles too, just different miracles than I did for different reasons, And I said, well, now I'm glad you finally, it took 5 hours. But everybody, Albert Einstein said there's only 2 ways of looking at the universe. Either that everything's a miracle or nothing is. And I think that really he thought of things as miraculous when you look at some of his other writings. This is Dr. Eugenie Scott, the head of the National Center for Science Education Incorporated, sort of a we are against creationists group, a private group. And look at what she said, and this is an attitude I've seen that frustrates me. Facts are a dime a dozen. There's facts all over the place. Theories are the most important thing in science. Now, I've met Dr. Scott, I've heard her speak, I've talked with her. She is a smart lady, and I know she knows she's bending stuff when she says something like this. Of course facts matter. She knows that. But what she's wanting to do is say, Big Bang theory, evolution theory. Let's talk about the theories. Let the scientists make the theories. Don't worry too much about the facts. There's so many facts. But if theories aren't fact-driven, I don't think they're worth that dime at all. Fact, logic, evidence, thinking, and the science has to be what we're about in science, or I'm really not interested. I got into science because the beauty of truths is what I wanted to discover. And so theories are people's constructs. They're interpretations of the facts, and theories can be tested. Yes, they can. How many heard that the CERN particle collider a year and a half ago proved the Big Bang? How many heard that it recreated the Big Bang? Okay, this would be like one of those crash dummy cars hitting a wall, and hubcaps and valve covers go flying everywhere, and pieces of the distributor and spark plugs, and at that we just proved how Ford made that car. No, we didn't. You see that the particle collider makes collisions and cracks open particles, and the subparticles go flying everywhere. And that gives us a clue of what a car's made of. Ooh, there goes a spark plug. Ooh, there goes a distributor cap. Well, in the old days we had distributor caps. And that does help us see what it's made of. It doesn't help us see how it was made any more than a crash of a car against a brick wall would show us how it was made. The CERN particle collider didn't recreate the Big Bang. People were worried it was going to create little black holes everywhere, and the whole Earth's going to get sucked in. Even Stephen Hawking said, well, that was ridiculous. He said, don't worry about that. If these little miniature black holes did form, they'd flicker back out of existence just as fast as they flickered in. And none of them actually did, but people were worried that we were going to make the Big Bang, we're going to blow ourselves up or get sucked into a mini black hole. So here we go. Andre Lind from Stanford, they have a collider there. 1994, again, Scientific American. The first and main problem is the very existence of the Big Bang. One may wonder what came before. If space-time did not exist then, how could everything appear from nothing? What arose first, the universe or the laws determining its evolution? Explaining this initial singularity, the little spot, single spot everything came from, and when and where it all began still remains the most intractable problem of modern cosmology. And of course that is the paradox, that everything came out of nothing for no reason. And that is the Big Bang Theory, which, if people wish to believe that, that's fine, that's well and good, but we shouldn't teach it as, hey, we know this is true, this is the only option. How many of you like Calvin and Hobbes? You can't teach science without Calvin and Hobbes or Dilbert, throwing in a little non sequitur, and Far Side.
The problem with people is they don't look at the big picture. Eventually, we're each going to die, our species will go extinct, the sun will explode, and the universe will collapse.
By the way, Bill Watterson was bringing forth the old oscillating universe theory, that the Big Bang, boom, and then gravity would bring all the galaxies back together, into what's called the Big Crunch. That's the oscillating universe theory. Bang, crunch, bang, crunch. And this would go on for eternity. And that explains why matter and energy are still eternal in the mind. Well, now since the Hubble constant has been recalculated, since Watterson did that cartoon, we have found out that the rate of expansion of the universe is going so much faster. The galaxies are flying apart from each other and are still accelerating away from each other. And that's still increasing so much that the term dark energy had to be invoked. Some force must be maybe anti-gravity. Since matter creates gravity, maybe the lack of matter creates anti-gravity is a new theory, but whatever it is, there must be something pushing them away, so they called it dark energy. And the chair of physics, a lady at Yale University 10 years ago, when she became the new chair, she was interviewed by Parade magazine, and she said, dark energy is just it's just code for we don't have a clue. And again, I think it's great when people who are put on a pedestal, sometimes I am, as intellectuals will admit, you know what, we're seeking just like you. We're feeling around in the dark. We have special skills of research and training and background, but we're figuring this thing out, and it's a beautiful journey, an immense adventure that we're on too. And it's fun for most scientists. And I'll broach that a little bit more later.
Existence is not only temporary, it's pointless. We're all doomed, and worse, nothing matters.
I see why people don't like to look at the big picture.
Well, it puts a bad day in perspective.
I suppose it does. But the oscillating universe theory is now gone because of the accelerating rate, and the Hubble constant has been readjusted. Now, Marilyn Beausavant is probably the most famous Mensa in the world. Myself and Dr. Bergman are both members of Mensa, the high IQ society. You have to get in the 98th percentile to get in an IQ. I say that not to brag, but to counteract the stereotype that all creationists have low IQ, the IQ of a land snail or a paper bag, and we don't. There are many brilliant creationists, there are brilliant evolutionists, but this brilliance doesn't shed light on events that happened in the past. That's all forensic science. Big Bang, origin of life, origin of species are the three miracles that have happened, and how they happened, whether it did it by itself, whether there's a box maker or the box made itself, of what Bruce was saying is really what it gets down to. But Marilyn Beausavant does not believe in creation, but she also won't buy the Big Bang. Now, she's in the Guinness Book of World Records, being the most famous Mensa in the world because her IQ is 228. I think the test only goes to 200, so I don't know how she pulled that out. But her column in Parade magazine is interesting. Look what she said. Be able to defend your arguments in a rational way. Otherwise, all you have is a what?
Opinion.
Opinion. There's nothing wrong with an opinion. Absolutely. Scientific investigation is launched by opinions and then research, experiment, hypotheses, and the vigorousness of that research may convert something in, it may be have conferred upon it the title of theory, and if we go far enough, law. But sometimes laws of science have had to be revoked because we were wrong, because humans are fallible. But that's the search, that's the quest that we're on. But if you can't defend it in a rational way, then you just have an opinion. Nothing's wrong with opinion, just don't package it and sell it as a fact and push it down people's throats. This is from her article here. Someone asked, as a non-scientist, how can I accept current scientific theories? For instance, the wave nature of light, when so many theories in the past later proved to be incorrect. And she goes into the Big Bang theory here, and let me give you bigger letters on what she says. That sounds just plain nuts, right? But do you believe it? If so, how do you support your belief that the entire cosmos was once smaller than a polka dot? With a strong line of reasoning, solid evidence, anything at all? If you cannot, welcome to the world of faith. You're accepting what you've been told by those you respect. Lots of science, far too much, is accepted on faith. And she says we must be careful not to teach theories as fact. It slows scientific progress immeasurably. Because if somebody just drops down into your database a theory as a fact, then you will exclude all curiosity outside of that paradigm, and you won't look for anything. That's why it took so long for people to accept Alfred Wegener's continental drift. That's why it took so long for people to even consider Big Bang, because there was a prejudice against the universe having a beginning of any kind, which is why the oscillating universe theory helped cosmologists who still wanted the universe to be eternal and have no beginning. Big Bang says there was a beginning, right? You know, the whole universe was in a hot dead state for nearly 14 billion years ago. Expansion started, wait. The Earth began to cool, Earth began to cool, the autotrophs began to drool, Neanderthals developed tools, built a wall, we built the pyramids. You know there's an error in that song? Because I'm a biologist. Autotrophs don't drool. For all these years, that I thought someone, I guess it'd be difficult to rehire bare naked ladies to sing the song over, but autotrophs are plants, heterotrophs drool. Anyway, it's like fingernails on the blackboard every time I hear that. Oh well. But if you teach a theory as a fact, it blocks people's minds out. They just think that's going to be a dead end. Why waste my energy going there? And she's right. Dogmatism in anything is not terribly healthy. We have to have things we all agree are laws, but you get the Nobel Prize if you disprove a so-called law of science. So there should be some actual impetus to doing that sort of thing. Marilyn Beausoleil also commented on the Big Bang saying, I believe that if a religion had been the first to propose the idea that all the matter in the universe at one time was concentrated in an area smaller than a pinhead, that probably the scientists would have smiled at such an idea. You know, oh, isn't that cute, you know. But it's actually a very religious concept, you know. Michael Roos, who has an endowed chairmanship at Florida State, he's an evolutionary philosopher, said, I can see why evangelicals are so alarmed by evolution. After all, the general evolution theory claims to answer questions that used to be the province of religion, like where did we come from? What's the purpose of life? Why are we here? Where are we headed? All those kinds of things, tautological type things. He said he understands, even though he's an atheist evolutionist, he understands why evangelicals would feel like someone's messing in on their territory, because these were always the province of faith. And if you base your life on evolution being true, you will come to different conclusions about those questions and many others. So it is a worldview. It is a faith position. This is Eric Lerner. He does not believe the Big Bang. He wrote a book called The Big Bang Never Happened. He is a cosmic string theorist, and he got together, made an open letter in New Scientist magazine in 2004, got like 33 other scientists to sign it. Now it's over 1,000 of them. And when it got up to like 400 and something, I checked the list. My old astronomy professor, Minos Kafatos, was on the list. So I knew there were other cosmologists. Not that they rejected the Big Bang, but they agreed with him, with Lerner, that the Big Bang is being taught dogmatically. Even if I believed in the Big Bang theory, I would be against it being taught dogmatically. And I've been in trouble with creationists and evolutionists sometime, because when I taught public school and when I taught in state community colleges, universities, and colleges, right now I'm teaching at a Christian college, so I can say what I want and say, and this is what we believe here. You don't have to. I can make a firmer statement. But when I taught at other colleges, and even still, I teach evolution theory. I teach the students what evolution says. I think if you believe in evolution, you're ignorant, and you can't discuss it intelligently unless you know what creationists really believe. And if you're a creationist, and you don't know what evolution actually says, you're ignorant. You see, no one should be about ignorance and dogmaticism. And actually, if you want to enter the discourse on these matters, you must become informed, and it actually behooves me to understand evolution better than almost everybody I've ever debated or discussed evolution with. I have to understand. They don't think they need to understand mine. They think it could all fit on a Sunday school flannel board. And that's just not, of course, so. So Dr. Lerner put this open letter, and we'll look at some excerpts from this open letter in 2004, which now has over 1,000. Now, let's first look at some, I told you, that Big Bang's fake. Let's look at the science fact I'm talking about. The first and the biggest one, I think, is the matter-antimatter calculation, a Big Bang model fail. And I have been on college campuses, given this presentation, many different places, and in most campuses, the students will say, well, my astronomy professor made us aware that this was one of the big problems of the Big Bang theory. So I hope that here at MSU that the professors are doing that. They're saying, guys, there's still many unanswered questions. Let's just be honest. I like the Big Bang theory. We'll pick up with it and run with it. As a chemistry teacher, I also teach chemistry. I know that the orbital hybridization theory, of molecular bonding is really not true. We know it's not true. We know it's a mathematical construct in a computer program, but it makes predictions that work for us and our chemistry works, but we all know it's not true. Someone's going to get the Nobel Prize if we actually find out how those orbitals do what they do, but orbital hybridization theory just isn't true. It's the best we got. So I could look at the Big Bang as being the best we got, and if I was a Big Bang believer and I was teaching astronomy, I'd say, it's the best thing we got. There are problems, and maybe someday we'll solve them, but the big one is the matter-antimatter calculation. Now, if you work all the equations for the Big Bang back to the beginning, you get that the universe was created with a 50-50 mix of matter and antimatter. Where is the antimatter, though? What we should see is a 50-50 mix of matter and antimatter, and what we actually do see in the universe is something much different than that. Only antimatter is extremely rare and fleeting, and there's a good reason for that. What happens if matter and antimatter touch if you're a Trekkie, They mutually annihilate one another. So if the universe actually turned out with kind of a racemic mixture of matter and antimatter at the beginning, Big Bang, full! And then all the matter and antimatter, that'd be it. In the matter-antimatter war, no one would be left, and it would all go back to being energy. And the universe would never have gotten started. And everybody knows this. Now, all the cosmologists in the world will know that what I'm telling you is true. This is an oversight of the Big Bang Theory, or something that's being overlooked on purpose so that we can at least continue talking about it, and that's fine. But it is a problem called the matter-antimatter problem. So what they did was insert a fudge factor into the equations, kind of like tampering with a long division problem, and you got a little remainder at the end. That little remainder is an extra amount of matter that was left after the matter-antimatter wars were over, and that little remainder of matter is us. The entire universe and all the stars and galaxies that you see through the telescope today, the Hubble Deep Field, 26 billion light years across a large area of the universe. And how does that work? It is somewhat related to the cosmological constant, which Einstein called the greatest blunder of my career. Every few years they resurrect that to hopefully to invoke it to explain something that we're having trouble explaining. If that was true, though, then protons would spontaneously decay like neutrons do. We call that beta radiation. But would protons spontaneously decay? We've never actually seen it happen. So I asked a doctoral student at University of Tennessee, Knoxville, I said, well, why don't we see, because I knew he was being taught Big Bang, and he was being taught that the fudge factor works. I said, why have we never seen a proton decay? He goes, well, that's because protons have a half-life of 10 to the 40th years. I'm like, oh, okay. 10 to the 40th is 1 trillion times 1 trillion times how old they think the universe is in the first place. So this is just putting it way out there, and this is imagination. I'm okay with imagination. I'm going with Barney. Let's use our imagination. I'm fine with imagination, but don't call it science yet. Don't call the Loch Ness Monster science yet. It'd be great if, Jacques Cousteau and his friends, if Philippe could catch one and they tried, and bring it in, and that'd be great. But we got to leave it out there as a fun, interesting idea until you actually have data. So that's where it's left. The matter-antimatter problem still exists. Now, I mean, there's not that many people here, but how many of you had a course here where the astronomy professor, mentioned this? A lot of times they do. Yeah, there you go. So they're not too shy about that. I applaud professors that do that. They might not spend a whole long time on it. They don't have to, but if they say, and this is one of the problems we still have to work out. I love Big Bang Theory, they might say, but this is one of the problems, and they admit it. Now, if you have a teacher who doesn't admit it, that doesn't mean that they're a liar or a sneak, but if then you ask about it in class and they get all fiery at you, now you think the person might have a little attitude problem going. I'm sorry, but that would be true if an honest question, it causes a firestorm back at you. That's why honest questions are encouraged and should be in all educational settings. Eric Lerner, in that article, Bucking the Big Bang, in New Scientist magazine in 2004, said this: the Big Bang Theory today relies on a growing number of hypothetical entities, things that have never been observed. Inflation, dark matter, and dark energy are the most prominent examples. 2004. He said, without them, there would be a fatal contradiction between the observations made by astronomers and the predictions of the Big Bang theory. Like the observations, the galaxies are accelerating, they're not decelerating away from each other. So we have to pretend something called dark energy exists. Something must be doing this acceleration, and there is a creation model for the universe for that. But something is causing it, so they just invoke the word dark energy, but we really don't know what it is. In no other field of physics would this continual recourse to new hypothetical objects be accepted as a way of bridging the gap between theory and observation. It would at least raise serious questions about the validity of the underlying theory. You see, there are contradictions between Big Bang predictions and the things we've actually recently seen through telescopes and radio astronomy. And that should cause a little tremor in the Big Bang community, and it ought to. And it shouldn't cause defensiveness, it should cause curiosity, and it should cause perhaps a little loosening the lid on the jar for opening minds. Now, the Big Bang theory fell out of repute, in the 60s when Penzias and Wilson discovered the CBR, cosmic background radiation, at Bell Labs in the late 60s. Radio astronomy was born, and cool developments since then. But that kind of boosted Big Bang theory. And then in the 90s, if you are a Trekkie, you see the Starship Enterprise is always running into a cosmic string, Rosal vortex things. They didn't talk about Big Bang very much during the 90s because cosmic string theory was really coming in as a replacement theory. It's like a beauty show or popularity contest. Then, at the end of the 90s, the thermal ripple was found at the edge of the universe using the IRAS, the infrared astronomical satellite, which that would be there if Big Bang was true. Now, there's 100 other ways that could be there, but since it didn't contradict Big Bang, it got applause and everything, just like the distortion in the cosmic background radiation did just earlier this year. Ever heard of this kid, Jacob Barnett? Jacob Barnett, he's at Indiana Purdue Fort Wayne, I believe is where he's enrolled. At 8 years old, he started his college career. At 12, he's got his bachelor's, he's on his way. He's 15 or so now. I saw him on a TED Talk. The kid is autistic, and he's also really smart, and he's learned to speak in front of audiences now, but this is when he was 12. I saw him on another talk show on TV too. At 12 years old, Jacob Barnett is a genius. He's already in college. His IQ is higher than Einstein's, and for fun, he's working on an expanded version of that man's theory of relativity. So far, the signs are good. Professors are astounded. So what else does a boy genius with vast brilliance do in his free time? Disprove the Big Bang, of course. And so the 12-year-old boy genius sets out to disprove the Big Bang. In the Big Bang theory, what they do is there's this big explosion and there's all this temperature going off, and the temperature decreases really rapidly because it's really big. The other day I calculated, they had this period where they supposed the hydrogen and helium were created, and I don't care about the hydrogen and helium, but I thought, wouldn't there have to be some sort of carbon? So what his line of thinking was that life on Earth is on the carbon cycle, and our planet is so filled with carbon, using the furnaces, the solar furnaces, fusion furnaces of stars to generate the higher elements just wouldn't be sufficient time to generate anywhere in the universe concentrated amounts of carbon like we have here. And he's saying it would have taken 7 billion years longer, and that just wouldn't happen. And maybe the Big Bang would have had to have made all the carbon, and maybe some could be, depending on what the Big Bang was really like. And so what he's decided the Big Bang should be done. I don't know, maybe he'll change his mind later, but I haven't heard anything since then about his Big Bang thinking. But he saw another chink in the armor of the Big Bang theory. Continuing with Dr. Lerner. So discordant data on redshifts, lithium and helium abundances. By the way, there should be different amounts of lithium and helium and other heavier elements. We should have a certain number of third-generation stars, and we don't. And we should have a certain number of first-generation that might be still observable. There should be more supernova remnant, more nebula with a little ex-supernova laying in the middle of it than we really have. There are a lot of little data problems, but I'm mentioning today the big ones for you. But redshifts, I'll go into that. data on redshifts, lithium and helium, and galaxy distribution, I'll go into galaxy distribution, among other topics, are ignored or ridiculed for the sake of hanging on to Big Bang steadiness, keeping the Big Bang theory steady and not letting the left side of the universe know what the right side is doing in your brain. Let's take a look at the galactic distribution that we were talking about just there. It's a fail for the Big Bang theory because the universe, it turns out, is galactocentric. How many of you have ever heard heliocentric and geocentric? Yeah, that's a theory about the solar system. Copernicus, disproved the Ptolemaic system. Galileo socked it in later, and Brahe and Kepler just made it, modified it a little bit, and socked it in also in the early 1600s. But now we believe the heliocentric theory. Now, a lot of people might think, the whole universe is geocentric. Earth is in the center. And that doesn't seem to be the case when we look at the observations. But surprisingly, for the past quarter century, all the data has been indicating our universe is actually galactocentric. Our Earth isn't in the center of the entire universe, but the Milky Way galaxy, and perhaps our portion of it, seems to be roughly at the center of the distribution. And one of the points of the Big Bang Theory is the universe has no edge and has no center. The universe has no center, but we're actually finding that it's kind of like layers of the onion. The universe is complex, like an ogre. Okay, it's complex layers of the onion. If you're a Shrek fan, you know what I'm talking about. Okay, and our little group called the local cluster seems to be at the middle of this. Well, let me show you what I'm talking about. First, a little bit about redshifts. If a galaxy is away from us and it's moving away from us, all of the dark bands in its rainbow spectrum, when we put its starlight through a spectrum, through a prism, and analyze it, the dark bands will be moved toward the red zone if it's moving away from us, moved towards the blue zone if it's moving towards us. For lay people in the room, light has different pitches. The highest pitch light is blue that we can see. The lowest pitch light we can see is red. Deeper than that is infrared. Higher than blue is ultraviolet. We can't see those. That's very, very high pitch light. Bumblebees can, though. Good for them. Boy, I'm trying to get biology in here anyway, and it can. Yeah. But it's kind of sound gets high pitched and low pitched too. If a race car comes at you, the sound gets lower pitch as it goes away. The sound gets higher pitch as it comes to you. Okay, so if something's coming at you with light or sound, any kind of wave, it'll get higher frequency, more waves per second, it'll come at you, more hertz, and it actually makes light look bluer coming from a galaxy rushing at us. It makes the light from it look redder if it's going away from us, and this is called Doppler shift, which I know you've heard of in weather forecasting, but it's on a big, big scale here. So if you have 2 galaxies, you have 3 galaxies, you'll find it turns out that galaxies further from us are actually moving away from us faster than the ones right near us. And we can gauge the distances. We can do a whole lot of other things that are cool looking at the redshift. But a galaxy 3 here further from us moving at a greater speed is going to be more redshifted. All of its stars are going to have light that's redder than it ought to be. And the dark bands in the spectrum will be moved down toward the red zone. What we should see, if the Big Bang is true, is an even distribution of galaxies all moving away from us, and we should see many different galaxies moving at different speeds away from us with no pattern. What we actually see is there's a whole bunch of galaxies this much redshifted, and then there's none this much. There are a whole bunch of galaxies that are this much redshifted, and that accounts for about 11 million light years apart. And for 11 million light years, there's nobody that distance from us. And then there's a whole bunch of galaxies moving that redshift from us. And so on. The redshifts are quantized. In other words, we see a bunch of galaxies around us at about 11 million light years away. Now, the local group is the only group of galaxies where some of them are blue shifted. A few other galaxies are actually heading towards us. Not very many, but only in the local group. Once you get outside the local group, there are no more blue shifted galaxies, the Virgo cluster and some of the other clusters. So this is a simplified version of it, but what we actually see is concentric 3-dimensional rings. They're really shells like balloons within balloons. And this has been confirmed. The universe is sort of Milky Way centric, local group centric, and there shouldn't be any center anywhere if the Big Bang is actually true. 1984, we knew this. There is now very firm evidence from the Astrophysical Journal. This is not the Creation Research Society Journal, by the way, which Dr. DeYoung is the president of the Creation Research Society. I'm a lifetime member of that. This is a Big Bang believing group that admit, hey, you know what? We've got evidence that the redshifts of galaxies are quantized. The Journal of Astrophysics and Astronomy, 1997, getting closer to the present. The redshift distribution has been found to be strongly quantized, amountized, in the galactocentric frame of reference. What does this mean for the Big Bang Theory? It's a problem. It actually contradicts the Big Bang Theory. Now, maybe this is a conundrum that can find some work-it-out solution, but not yet. And it is another condemning thing for teaching Big Bang as anything but a nice idea. Again, 1987, Halton Hart, from a book, I believe that is, the fact that measured values of redshift do not vary continuously but come in steps, certain preferred values, is so unexpected. Why? Because Dr. Hart believes the Big Bang Theory. It's so unexpected that conventional astronomy has never been able to accept this in spite of the overwhelming observational evidence. Remember what Dr. Lerner said. Observations and data have been ignored or ridiculed in favor of Big Bang Theory, and that's not healthy in science. Observations are now interpreted through this bias filter, says Dr. Lerner, judged right or wrong depending on whether or not they support the Big Bang Theory. Again, that's that letter, open letter, that he published in 2004 in New Scientist magazine. Implications of this now, to be fair, Dr. D. Russell Humphreys is a creation scientist. I've spoken with him on the same platform before. He's a retired physicist from Sandia National Laboratories. He's won awards. He has patent for his magnetic thermocouple switches. High energy physics is his field. And this guy is the one who correctly predicted the magnetic field strengths of the planets Uranus and Neptune before the probes got there. NASA's prediction was off by a factor of 1,000,000 times wrong, and they're kind of freaked that Dr. Humphreys was right. That's cash in the bank if your theory predicts things. You know, Einstein's theory predicted the bending of starlight, and Humphreys' theory on planet formation predicted the magnetic field strength should be as weak as they are today. He also correctly predicted the strength, the weakening of Mercury's magnetic field just a couple of years ago. Once the MESSENGER probe entered stable orbit around Mercury, for the first time a probe had measured the field since 1975, and that was the Magellan probe, and he was right about that too, within parameters. It was pretty cool. But anyway,
also the moons of Jupiter.
One of the what I'd consider one of the great scientists, research scientists in the creationist community. But he pointed this out. The quantized distribution of galactic redshifts observed by various astronomers seems to contradict the Copernican principle and all cosmologies founded on it, including the Big Bang cosmology. Now we're getting away from the galactocentricity. How about how galaxies form? How does an explosion actually form beautiful, highly structured arrangements of matter and energy, which we call galaxies, galaxy clusters, and large-scale streams of galaxy clusters in the gross structure of the universe? How does that happen? James Trefle, who teaches at this time taught at George Mason University, where I got 3 of my degrees, and he and Robert Hazen wrote a book, Science Matters, which I loved. I used it as a textbook for a class I taught in Vermont. But he said this, there shouldn't be galaxies at all. And even if there are galaxies, they shouldn't be grouped together the way they are. The problem of explaining the existence of galaxies has proven to be one of the thorniest in cosmology. Astronomy is, looking at stars and things. Cosmology is referring to the structure of the universe, not necessarily the things we see in it, but the arrangement. By all rights, they just shouldn't be there. Yet, there they sit. It's hard to convey the depth of frustration that this simple fact induces among scientists. But that cognitive dissonance is a good thing in science. It energizes and gives the impetus for new research and new theories, which is good. It's not comfortable, as Dr. Trefle says, but he is admitting it's a fact. It's a fact. Remember what I said a long time ago at the beginning of this, and when I gave my intro in the big group, I'm looking at the facts of science. I'm looking at the data of science. I'm looking at the established laws of science. I think the laws and the theories and the hypotheses are nice, but the facts, observations are irrefutable. Well, how do you know your senses aren't lying to you? All truth is relevant. Okay, fine, and you can't prove anything. That's right, Dr. Jackson, you can't. Well, you can't prove what you're saying either. No, I'm empirical, you're not. No, that doesn't work. It's got to work both ways. If nothing's knowable, then don't complain to me. And don't exclude my ideas being taught in a university either. Eric Lerner again in that same open letter. This reflects a growing dogmatic mindset that's alien to the spirit of free scientific inquiry. Now, whether you believe in Big Bang or cosmic string theory or steady state theory or whatever, you know, the theory that God made the universe and stretched out the heavens, white hole cosmology, or not, whatever you believe, dogmatism should not be a part of your mindset. And we all have to fight it because you all have our favorite theories. You know, Humphreys, he's my man, you know, I love him, I like his personality, I like the way he presents, but he also says, look, I could be completely wrong with white hole cosmology, but here's the theory, and I think it's cool, and I think it's cool too. It answers a lot of questions. Okay, that's the, what was that? Oh yes, the galaxy formation fail, the star formation fail for evolution. In the cosmology universe by Big Bang Theory, and Mr. Malone mentioned that also. Star formation, he did give you a lot on that. Let me just give you this. This is from 1990. This is still true, Science magazine. Most disturbing, however, is the fact that despite numerous efforts, we have yet to directly observe the process of stellar formation. We've not been able to unambiguously detect the collapse of a molecular cloud core or the infall of circumstellar material into an embryonic star. Until such an observation is made, it would probably be prudent to regard our current hypotheses and theoretical scenarios with some degree of suspicion. That's honest. That's honest, and it hasn't changed since 1990. Just a few months ago, again, maybe it was late last year, they were saying that there was some bright spot in a cloud of gas, and as Mr. Malone said, it was really a star shining from behind when part of the cloud looked a little thinner. I've had evolutionists saying, well, Dr. Jackson, the reason is because it would take a long time for a star to warm up. So brown stars, you know, like Barnard's star, that's a star gradually coming into being. We don't see those in those nebulae where they're supposed to, the Trifid Star Nursery, or the Eagle Nebula, or the Orion Nebula, where all these baby stars are supposed to be born blue, white, hot. You know, fusion is a chain reaction. A star shouldn't just brown in over centuries and centuries of time, so gradual, so slow we can't notice it. No, it's a thermonuclear detonation. A star being born should happen within a few hours. It's a chain reaction. A star would flicker into existence where there used to be a black part of space. A new star should be sending off new radiation, and you should see it one night and it wasn't there before. It would happen suddenly just because of the nature of fusion chain reactions. And everybody knows this. To have somebody tell me that in a public forum is a sign of wishful thinking, maybe some ignorance, certainly hoping to make me look bad in front of an audience, but when you actually bring up, it's a chain reaction, everybody knows those go fast, like it's the exact same reaction as occurs in a thermonuclear detonation. And we haven't been able to control that yet, cold fusion, no kind of fusion reactors. It's only a bomb as far as we know, just like the sun. It hasn't ever been seen, and it can't be for the reasons that we already talked about, the pressure, the gravity, and what hot gases do, and what gravity can't do. Of the four known forces in the universe, gravity is the weakest of the four. And so you have to have a huge amount of matter, like an 8,000 mile thick chunk of rock like our planet, to even get me to come back down after this, you know. Jump off Phobos and you might end up in orbit. Okay, how many have heard of the Planck constant? The Planck constant, well, there you go. I'm not talking about Ed and Eddie's Planck, okay? If you know that cartoon. Max Planck was a personal friend of Albert Einstein. He was a Nobel Prize winning physicist, Look at what he said. Whenever an experimental finding contradicts the accepted theory, another step on the ladder of progress is thereby announced, for the contradiction signifies that the accepted theory must be overhauled or improved. Now, one more that I want to discuss is the C fail. E equals mc squared. What's that? Yeah, Einstein's equation. C, okay, E equals energy, M equals what?
Mass.
Matter, okay, mass, and C is the speed of light. A large number, 300,000 kilometers per second, or 186,000 miles per second is the speed of light. Carl Sagan called it the speed limit of the universe. Okay, it's a known law of science. According to Albert Einstein, nothing can go faster than the speed of light. Anything trying to do that will just turn into a ball of energy, and after that weird stuff happens, and Superman really can't go back to when Lois Lane got in the earthquake crack. You can't go backwards in time. You could maybe slow down your progress in time, but you can't go backwards. C is also a problem for the Big Bang Theory. Albert Einstein and his theory, he also said, and this is a sign of the death of a theory, everything should be made as simple as possible, but not simpler than that. You see, during the first trillionth of a second of the universe, the Big Bang Theory says there was a stage called the inflationary period. How many ever heard of the inflationary period? Yeah. And during that time, the universe would have had to popped out like a spring-loaded umbrella to a huge size within a trillionth of a second, and it would have required matter and space and time and energy to travel faster than the speed of light. Now, this is completely acknowledged and swallowed as a tough pill to swallow, but it requires a breaking of the law that nothing can go faster than the established speed of light, even in a vacuum. And that violates that. It violates the first law of thermodynamics that says that matter and energy can't be created or destroyed, because it says it was all created in that trillionth of a second. And it also violates the second law of thermodynamics, which says everything going to entropy, the random state, and yet gravity, which is the weakest force in the universe, somehow managed to go against the chemistry 101 gas laws, PV equals nRT, Charles's law, Boyle's law, the combined gas law, and that gases could somehow combine. Now, there are many dog-ate-my-homework stories, like the fudge factor and the matter-antimatter thing, that apply to the stellar evolution or star-forming problems, and also to the C problem. Here's sort of a little chart here. If you can't say it simple, Einstein said, you don't understand it well enough. But the Big Bang Theory has had to become a more intricately interwoven and convoluted complexity mathematically and schematically, and that's usually the sign of the death of a theory. The geocentric theory of the solar system, once new observations came in, it looked right for 1,500 years, and then we had new data come in, especially from Tycho Brahe and Galileo and Brahe's apprentice Kepler, that just destroyed that theory because new evidence came in. But they had to make dog-ate-my-homework stories. Okay, Mars looks like it's going backwards, and geocentric can't explain that, heliocentric could, but no, we're not going there. Mars makes little curly cues like the frosting on top of a Hostess cupcake, and they called these epicycles, as it went around a main orbit called the deferent, anything to explain how Mars could appear to go backwards during part of the observation from Earth during its orbit. And so it just got more and more complicated. It's normally the sign of the death of a theory and ushering in a new paradigm. The knowledge we had of the elements of the universe was filled books and books and books and books until Dmitri Mendeleev, with the help of Newland's law of octaves and Dobereiner's triads, the brilliance of Mendeleev was it all collapsed into one simple, beautiful Rosetta Stone, which he called the periodic table, the elements, and now it's on every wall in most science classrooms and every chemistry classroom because it simplified what had been a mess. the theory of everything, or the grand unification field theory that Einstein was looking for when he died, and Stephen Hawking sure wants to discover, and so does everybody else, would simplify everything. I mean, Albert Einstein complemented classical Newtonian physics with 3 equations. I mean, 3 variables in an equation. And if you've seen the Schrodinger wave equation, 3 variables is really little to explain the whole universe. And Einstein practiced what he preached. Make it simple, but not simpler than that. And Big Bang, just as an aesthetic, is got too many ifs, ands, or buts, too many dog ate my homework stories, too many, well, let's ignore that for this time and ignore actual laws of science and observations. I think that's a problem. I don't think it's a problem to teach it. I think it's a problem to teach it and not bring up the warts on this, okay, the little patchinesses. You really should admit that. And perhaps even acknowledge that there are other models and ideas out there. I like Nikola Tesla. He was 50 years ahead of his time at least. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation, and eventually build a structure which has no relation to reality. And I believe that happens far too often. Don't forget, there's a great payoff for being the person who's famous for a particular theory, you see, and for getting on that bandwagon and teaching it in your classes. Okay, so there's some contact information for me personally back at Creation Truth Foundation in Noble, Oklahoma, and that's my Facebook page. That's our Facebook page, and my email address at Creation Truth.